Okay, this is the summary for Lesson 3 from Unit 1. The title of Lesson 3 is Grid Moves. And in the summary, they summarize using two different grids. One grid is just regular graph paper in which you can show 90-degree rotations, any multiple of 90 degrees, and even 45-degree rotations if you want to look at that diagonal of the square. The other type of grid is an isometric grid, which you can use to show 60-degree rotations. So you can rotate 60 degrees because the angle formed by the sides of an equilateral triangle is 60 degrees, or you could go halfway and show a 30-degree rotation. So 90-degree rotations with regular graph paper and 60-degree rotations with the isometric grid paper. So the first thing that they summarize is a translation. And I'm going to show you a little video here. So the idea is to translate that image, A prime, B prime, C prime, D prime, well it's actually A, B, C, and D, to A prime, B prime, C prime, and D prime. So I'm going to just lay that over. I'm going to translate that image. And in the text, they use the description of moving 4 units to the right and 3 units down. So they use a counting strategy to move the image. So I'm going to move that image. I'm actually looking at where C ends up compared to A. So I move C 2 spaces down from A, and I'm sorry, 1 space down, 1 unit down, and 2 units over. All right, so using Doceri, you can snap straight lines from C to C prime, and then I can make a copy of that line and fit that to each of the other points, because every single point is the same distance from its corresponding point, and it's in the same direction. So you can just copy the line segment and move it over, and it should fit right in there, and it does. So that's a demonstration that that's a translation. It translates parallel, and you actually get that prism once again. So the blue bases of the prism, and then the green parallelogram connections. The summary does not include rotations of 90 degrees, so using a grid to rotate an image 90 degrees. But I want to go over this one more time, so I'm going to use the same image that I just used in the translation and show you 4 90-degree rotations. And so if you start, if this is point A right here, and that is, I should have labeled these A, B, C, and D. So A is 3 units from the center and 2 units in the direction of rotation. So for each of these points, you're going to have 2 values. One value, and call it the first value, is going to be the movement, the distance from the center of rotation along an axis, either the x-axis or the y-axis. And the other value is going to be the units in the direction of rotation. So in this case for A, you're going to move 3 units from the center of rotation, and then 2 units in the direction of rotation, and that in this case is 2 units clockwise. So here's A, and so it's 3 units along the axis from the center of rotation, and then 2 units in the direction of rotation. So A ends up here, and then A is going to rotate 90 degrees over to this point right here. So it's 3 units from the center of rotation along the axis, and 2 units in the direction of rotation. And then A is going to rotate again 90 degrees to right here. So it's 3 units along the axis, and 2 units in the direction of rotation. And finally it's going to rotate again to this point right here. So 3 units along the from the center of rotation along the axis, and 2 units in the direction of rotation. Do it one more time, you end up back where you started. So if you do that 4 times, you end up where you begin. 360 degrees divided by 4 is 90 degrees. So each of these rotations is 90 degrees. So it's one way of demonstrating or showing or proving to yourself that these are in fact 90-degree rotations. You connect the points, you also get a square. Alright, so if you look at B, B is 5 units from the center of rotation and 2 units in the direction of rotation. So it's 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. And C is 5 units from the center of rotation and 4 units in the direction. So 1, 2, 3, 4, 5, 1, 2, 3, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. And finally D, is 6 units from the center of rotation. 1, 2, 3, 4, 5, 6. And 3 units in the direction of rotation. 1, 2, 3. So you place all 4 of these points and connect them. You get that image. Then you rotate them in the same way. Connect the points. You get that image, and so on. So it's a way of showing a 90-degree rotation. All right, so 60 degrees. We're going to use isometric grid paper to show 60-degree rotations. And so this image right here is going to rotate to the blue image is going to rotate 60 degrees to the green image. And it's pretty easy to see point K going to point K prime. This is 60 degrees. It's the sides of an equilateral triangle form a 60-degree angle. And so this length right here, KL, rotates 60 degrees. And it ends up as K prime and L prime. So that's not too bad. You can use the grid to see that. You can also use the grid to see M going to M prime. Again, it's not too bad because it goes through the center of the equilateral triangles. Well, those are, that's a 30-degree rotation from here to here, and another 30-degree rotation. So look at this as a big equilateral triangle. So it's 30-degree rotation halfway, and another 30-degree rotation. So 30 plus 30 is a 60-degree rotation. So you can also see M going to M prime. Not too bad. But to see that N going to N prime is also a 60-degree rotation, that's a bit harder. You can kind of tell that this is a little bit on the inside of this side of the equilateral triangle, and this is the same distance on the other side of the equilateral triangle. So you can probably reason that this is a 60-degree rotation. And by the way, if one point rotates 60 degrees, they all have to rotate 60 degrees. These are called rigid transformations because the shape remains rigid. It does not change relative to the points within the shape. They move, but they all stay within the same relative position. But let's take another look at N going to N prime, and let's use a counting strategy, much like what we did for the 90-degree rotations. I have a little video here. So if I draw the segments and if I count along the isometric grid paper, 1, 2, 3, and then 1 unit in the direction of rotation, and if I make that same count along the other side of the triangle and 1 unit in the direction of rotation, you can argue that that is a 60-degree rotation. You're going the same number of units along the side of a triangle and then 1 unit in the direction of rotation. So that's a 60-degree rotation. Once again, if you can show that one point rotates 60 degrees, they all rotate 60 degrees. And finally, if you, in Docere, you can just grab the image and rotate it 60 degrees. So here's P is at the center of rotation. It's going to go through these 2 points. So this is a 60-degree rotation going from K to K prime. So I'm just going to grab this whole image and rotate it 60 degrees around this arc from this point to this point. So this is a nice thing about Docere. You can select that image, and now I'm just going to copy and paste it, and I'm going to put it back where it started, but now I'm going to rotate it around. So as I go, I'm going to twist it around. So it's rotating, 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 rotating. You're going to see that it's going to land. If K rotates 60 degrees, all the points rotate 60 degrees. So that image is going to land right on top of the green copy. So that is a 60-degree rotation.